since we started the conversation earlier today, something being in my head, it pertains to the no need of evaporation when you utilize the EXTREVA ASE versus the method as prescribed, and not because the EXTREVA ASE cannot accomplish this task. So can you walk us again why evaporation is not needed in this method that was developed by Thermo Fisher Scientific?
So as I said before that with EXTREVA ASE, our primary goal is to basically bring the automation and basically streamlining the different steps in EPS 1633 while keeping the chemistry same.
Right.
So if you look at the EPS 1633A and their evaporation step, what they do is basically after the extraction, they evaporate it down and then they bring the volume up. So for us, it's like a redundant step.
Okay.
You can do it the other way. So what I mean is, when you have your extract, you can basically dilute it with DI to bring your organic percentage below 20%.
Right.
What that will do is basically that you are bringing a little bit larger volume to your SP step.
Right.
But if you look at the overall process, we are still reducing the turnaround time significantly.
Right. And we're talking about, when we talk about reduction of turnaround time, what is that? If we could quantify it, what would be that number?
Overall, the turnaround time is 30% less with EXTREVA ASE.
By not going through this redundant step of evaporation. What else do you gain by not evaporating?
Yeah, so if you eliminate your evaporation step, basically you are reducing your sample handling.
Right.
And in terms of PFAS, I mean, if you can reduce sample handling, you are basically reducing your risk of contamination.
Right.
So that, which is a huge problem for PFAS testing.
And I would guess also some of these compounds tend to be a little bit volatile, right?
Yes.
So,
So if you eliminate your evaporation step, you are reducing that also.
Right. So even with an automated system, that's the intrinsic nature of these molecules, I would guess, right? So it's expected for that to happen, right? So not to deviate from the main topic of today's conversation, right? So we know that for PFAS, evaporation is not needed. It would be a redundant step. But will be those cases where we could use the full potential of the EXTREVA ASE system and where evaporation could actually be a game changer?
Yeah, what's really important are methods like 8270, where you have to do solid samples, or dioxins, okay, because those require very low detection limits in terms of regulation.
Right.
Dioxins are regulated at subpart per trillion levels.
Right.
And so that evaporation step will be necessary to make sure that you're able to meet the detection limits in those methods. So what's great about the EXTREVA ASE, however, it's like walk-away evaporation. It will take care of the evaporation step, and what's nice is when the evaporation gets down to the level it needs to sense and stop, it will stop automatically as it has a really advanced detector to sort of stop that evaporation. And it'll also leave it in the autosampler vial.
Correct.
That way you can take the autosampler vial and walk it up to your LCMS-MS or GCMS-MS system and do the analysis. And so that's really important because, again, avoiding the transfer and that evaporation step is really critical to be able to hit those detection limits in those two particular methods.
That's excellent. So basically what we're hearing is that EXTREVA is a very versatile instrument. I mean, definitely cases like PFAS, we won't go through the process of evaporation. In cases like dioxins, definitely we would like to go evaporation route in order to reach the proper limits of detection. What do you think is the future of this instrument in PFAS world, Ed? Like, Gopal and the team have done an impressive work covering all the matrices related to EPA 1633, which is mostly environmental testing. Where do you see us going with the instrument, knowing the capabilities?
Yeah, what's really nice is that the regulations are starting to branch out, right? So obviously it started with the Environmental Protection Agency when they knew that PFAS was everywhere in the environment.
Right.
That concerned them a lot.
Right.
Now we're starting to look at other matrices like cosmetics and textiles and food contact materials, even some of this dark matter in lithium batteries. So a lot of matrices that would apply to the EXTREVA ASE for PFAS extraction. And there's a big concern because we don't know how much PFAS is in these materials. All we know that it's present, and we don't know how much is getting into landfill leachates and other places where it's adding to the environmental contamination. So not only environmental, but all these other sources. We also have food, which is just beginning to be regulated, and it's looking like when you start to look at food, that could be a more major source of PFAS than even water. So that's sort of coming out now in some of the later academic circles. And so it's a real concern. And so the EXTREVA ASE is well positioned to automate extraction of those types of materials.
That's excellent, right? So we're definitely looking forward to a world where EXTREVA not only solves problems from an environmental perspective, but also from consumer products and whatnot.
Yeah, because these companies are really trying to look at their process, and they're being forced to remove PFAS from their raw materials.
And guarantee that.
And guarantee, but it's not easy. Why? Because PFAS have very interesting chemical properties. They're anti-slip and anti-moisture resistant, right? And so finding a material to replace a PFAS is very difficult. Just like in the past when they had the RoHS initiative where they were looking at lead and cadmium in circuit boards, the same thing's happening here. How do we replace those materials? But then how do we replace it with a safe material, a safe and effective material? That's the critical thing. And the semiconductor industry is really trying to look at that as well. So big companies are saying, how do we get rid of it out of our process? Because what's happening is that PFAS being used to create some wafers and other things in the semicon industry is ending up in the wastewater and being dumped back into the environment. So it's a big circle of problems that need to be solved here.
And it's a big circle where EXTREVA ASE could intervene and then provide a solution for our customers. Awesome, thank you very much.